organization of muscle fascicles and their role in generating force, or we can say briefly that it is pattern of fascicles. That is what we're talking about today. Welcome to Teacher Gia's channel, and let's begin. So our learning objectives are, by the end of this section, you will be able to explain how fascicles are arranged within skeletal muscles and understand how these arrangements affect muscle function and force production. So let's begin. Skeletal muscles are made up of bundles of muscle fibers called fascicles, which are surrounded by connective tissue. The organization of these fascicles play a key role in how much force a muscle can generate and its range of motion. So I hope you've understood that skeletal muscles are made up of bundles of muscle fibers called fascicles. So a bundle of muscle fibers are called fascicles, okay? Let's break it down. Here we're going to talk about some keywords that are used and their meaning and function. Connective tissue layers. So you have endomysium layer, which covers each muscle fiber. You have perimysium, which is a layer that surrounds each fascicle, which is a bundle of muscle fibers. Epimysium is a layer that wraps around the entire muscle. So a fascicle is a bundle of muscle fibers. Endomysium is a layer that covers each muscle fiber. Perimysium surrounds each fascicle. Epimysium wraps around the entire muscle. The way fascicles are arranged within these connective tissues determine the muscle's shape, strength, and movement. So, common fascicle arrangements. The first one is parallel muscles. Here, fascicles run parallel to the muscle's long axis. Example, sartorius, which is long and flat, biceps brachii, which is fusiform with a central muscle belly tapering at the ends. So the function of parallel muscles, like these muscles have a good range of motion but produce less force compared to other arrangements. So if you see a muscle whereby at the center is a bit wide, then towards the two ends is thin, then that is a parallel muscle. Secondly, we have circular muscles. Here, fascicles are arranged in rings. Examples, orbicularis oris around the mouth and orbicularis oculi around the eyes. So the function acts as sphincters, controlling openings in the body by contracting or relaxing. So any circular muscles which are arranged in rings, that is it. So we move to convergent muscles. They have a broad origin with fascicles converging towards a single tendon. Example, pectoralis major. Functions of convergent muscles allow versatility in movement and generate moderate force. We have pennate muscles, which are feather-like. Here, fascicles attach at an angle to a central tendon, increasing the number of fibers in a small space. We have subtypes of pennate muscles. We have unipennate, which are fascicles on one side of the tendon, e.g. extensor digitorum. You have bipennate, which are fascicles on both sides of the tendon, e.g. rectus femoris. And you have multipennate, fascicles attached to multiple tendons, e.g. deltoid. So functions of pennate muscles. These muscles generate more force but have a limited range of motion. I have a lesson where I talked about pennate muscles at length, which are unipennate, bipennate, and multipennate. I'll put the link in the description so you can check it out. We move to how fascicle arrangement affects muscles force. Okay, so the arrangement of fascicles determines force. Pennate muscles can pack more fibers, making them stronger but less flexible. Range of motion. Parallel muscles can stretch and contract over a longer distance, providing a greater range of motion but less force. So with the examples given, you can clearly see how arrangement of fascicles determines the force and range of motion. So we move to lever systems in muscles. Muscles work with bones to form levers. This system includes, we have fulcrum, which is the joint, effort, which is the force applied by the muscle, and load, which is the weight or resistance being moved. There are three types of levers. We have first-class levers, e.g. neck muscles lifting the head, balanced between speed and power. You have second-class levers, e.g. standing on tiptoes, which optimize strength, and third-class levers, e.g. biceps flexing the forearm. This prioritizes speed and range of motion. So that is all about levers in muscles. In summary, muscle fascicle arrangements and lever systems work together to balance force and motion. Understanding these patterns helps explain how different muscles perform their functions, from generating powerful contractions to enabling quick movements. And that is all about organization of muscle fascicles and their role in generating force, or we can say fascicle patterns. So I hope you've learned something, and don't forget to like, share, and subscribe to Teacher Jess channel. See you in the next lesson.